All right, so today we're diving into something pretty amazing. We're talking about a brand new material, a revolutionary one actually, that tackles two of the world's biggest problems all at once. I'm talking about our mountains of plastic waste and the growing need for clean water. It honestly sounds like something straight out of science fiction, but I promise you it's very, very real. So let me ask you this. What if we could take our plastic trash, that bottle you just finished, and turn it into something that creates fresh, clean water? It's a pretty wild idea, right? Okay, so before we get into the nitty-gritty of how this works, we really need to get our heads around the scale of the problems we're facing. It's huge. So you've got these two massive global crises, right? First, fresh, clean water is just getting harder and harder to come by. And second, our planet is absolutely choking on plastic waste. Now, sure, we have ways to get fresh water, like reverse osmosis, but here's the kicker. Those methods use an insane amount of energy. They're just not a practical solution for a lot of the world. And that brings us to a much, much smarter idea. What if we could power the whole process with the biggest, most powerful, and totally free energy source we've got? Yep, I'm talking about the sun. The basic idea behind solar desalination is actually beautiful in its simplicity. You just use sunlight to heat up salt water. The water, well, it turns into vapor, leaving all the salt and gunk behind. Then all you have to do is catch that pure water vapor and let it cool back down into clean, fresh water. It's clean, it's simple, and it should be super cheap. But, of course, there's a bottleneck. There's always a catch, right? To make this whole thing work efficiently, you need a very special kind of material. Something that's just ridiculously good at soaking up sunlight and turning it into heat. And finding that perfect material, well, that's been the real challenge for scientists for a long time. That is, until now. And this is where things get really genius. This is the big aha moment. Because researchers found the perfect starting point for this material in something we have way, way too much of. All those discarded plastic bottles. Okay, so check this out. Here's the whole process in a nutshell. You start with a regular old plastic bottle. It goes through some clever chemistry, gets a coating of some special crystals, and what comes out the other end is this amazing high-tech foam. You just put this foam in salt water, let the sun hit it, and boom, you're making fresh water. So how exactly do they pull this off? Well, it's basically a two-step recipe. First, they take that waste plastic and they upcycle it. They turn it into this black foam that's super porous, almost like a sponge. And it's hydrophilic, which is just a fancy way of saying it loves water and soaks it right up. Then comes part two, the secret sauce. They coat this foam with a very special nano-engineered layer of crystals. All right, so let's talk about this special coating, because it's not just some simple layer of paint. This is what makes the whole thing a rock star. Okay, if you could zoom in with a super powerful microscope, this is what you'd see. It's incredible. The coating isn't flat at all. It's like a tiny, microscopic forest of nanosheets, all standing straight up. And this structure is just genius. It creates all these nooks and crannies that are absolutely perfect for trapping sunlight, no matter what angle it comes from. Plus, it gives the water a massive surface area to evaporate from really, really fast. Now, the actual chemistry of these nanosheets is pretty complex. It's what's called a heterostructure. You can just think of it like a microscopic sandwich with two different layers. The specific materials are a combo of two sulfide compounds. Now, don't worry about the names. What's important is why they were chosen. They were picked because, together, they can absorb pretty much the entire spectrum of sunlight. Not just the light we can see, but UV and near-infrared too. And that's where a ton of the sun's energy actually is. Okay, so the science is cool, for sure. But the real question is, does the thing actually work? Because at the end of the day, performance is all that matters. Let's check out the numbers. First up, how well does it soak up the sun? The answer, an incredible 96%. It absorbs 96% of all of the solar energy that hits it. That is just exceptionally good, and it's the whole foundation for why this thing works so well. And here, this is where you really see the magic happen. Let's look at how fast it makes water evaporate. The original foam by itself, it's okay, not bad. But look at the final material with that special coating. We're talking 2.82 kilograms of water per square meter per hour. That's nearly double the rate of the foam alone. That's not just a small improvement, that is a massive leap forward. And hey, you don't just have to take my word for it. Here's the proof you can see. These are thermal images. On the left, you've got the plain foam, and it heats up to about 68 degrees Celsius. But look at the right. That's our new material. It gets way hotter, over 76 degrees. And it's simple physics, right? More heat means more evaporation, and a whole lot faster, too. Of course, making water evaporate fast is great, but it means absolutely nothing if the water that comes out isn't clean. And this might be the most important number of all. The system removes about 99% of the salt. It takes salty brine and turns it into fresh, pure drinking water. Mission accomplished. So let's zoom back out. What does all of this mean for the big picture? Because this is way more than just a cool lab experiment. This could be a real roadmap for how we deal with some of these huge global problems. And just to put this thing's performance into perspective, take a look at this comparison. Here are some other really advanced materials that have been developed recently for the same purpose. You can see they're all pretty good, hovering around that 2 mark for evaporation rate. But our new material, it just blows past them, hitting 2.82. It's really in a league of its own right now. So when you step back and look at it, what we're really seeing here is a perfect example of what people call a circular economy. You're taking something nobody wants, plastic trash, and turning it into a high-value solution to a life or death problem. It's low cost, it's sustainable, and it could bring fresh water to people who need it most. It's one single idea that attacks 2 giant environmental crises at the same time. It's just brilliant. You know, a breakthrough like this really makes you think. It just shows the incredible potential that's hiding in plain sight in all the stuff we call waste. And that kind of leaves us with one last question to chew on, doesn't it? What's the next piece of trash that we can transform into a solution that could change the world?